compounds and writing chemical formula. First, let me define compound. Compound is composed of two or more elements chemically bonded together. The examples of common compounds are the CO2 or the carbon dioxide and the NaCl or the sodium chloride. Now, what is nomenclature? Nomenclature is a collection of rules for naming things, is important in science and in many other situations. It can be defined as terminology of chemical compounds. It represents the basic language of chemistry. So talking about nomenclature, here in chemistry, so I am talking about the chemical nomenclature in terms of the rules and procedures in naming compounds and writing chemical formula. Now, let us go on with the rules in naming compounds. First, let me discuss what are the different kinds of compounds. So we have what we call the binary compounds. The binary compounds are categorized into two. It can be binary ionic compounds or binary covalent compounds. So talking about binary compounds, from the term bi, it means two. So binary compounds are made up of two elements. The second one is what we call the ternary compounds. So when we say ternary compounds, if the binary are composed of two elements, ternary compounds are composed of more than two elements. Now, let us go on with the binary ionic compounds. So under the binary compounds is the binary ionic compound. So a binary ionic compound is a compound composed of a monoatomic metal cation and a monoatomic nonmetal anion. So in other words, or in simple explanation, when we say binary ionic compound, these compounds are composed of one metal element and one non-metal element. Now let us go on with the rules in naming binary ionic compound. So the first one, or the first rule, is the cation is written first in the name, the anion is written second in the name. So cation refers to metals, anion refers to non-metals. So in simple explanation, metals is written first, followed by the non-metals. Rule number 2, the name of the cation is the same as the element from which it is derived. Okay, let's say for example, Na. The elemental name of Na is sodium. So since Na is a metal, it will be named to its elemental name, which is sodium. So rule number 3, the anion is named by adding the suffix IDE to the root of the elemental name. Let's say for example, I. So the elemental name of I is iodine. So by getting the root of the elemental name and adding the suffix IDE at the end, the name of the iodine will become iodide. So let's say for example, our compounds are composed of sodium and iodine, so the name will become sodium iodide. Okay, more example, naming binary ionic compounds. So we have the formula and the name. So in the formula, we have the Kf. So the elemental name of the K is potassium, and then F is fluorine. But by adding the suffix IDE to the root name or to the root word of the elemental name of fluorine, it will become potassium fluoride. So the second one is we have Na3N. So Na means sodium and N means nitrogen. So again, we are going to name the metal to its elemental name. So Na is sodium, while N, instead of writing nitrogen, we're going to get the root word of the elemental name and then add the IDE, it will become nitride. So it is sodium nitride. And then the third one is Ca3P2. So Ca, or the elemental name of Ca, is calcium, while P is phosphate. So again, we are going to name the metal to its elemental name. So Ca is calcium, while the phosphate, we are going to add the suffix IDE to the root of the elemental name of phosphate, it will become phosphide. So Ca3P2 is calcium phosphide. Okay, example or another example. We have the NaCl. So Na, the elemental name of the metal Na is sodium. So Cl will be named as chloride. Adding the suffix IDE to the root of the elemental name of chlorine. That's why again it became chloride. So NaCl is sodium chloride. Another example is KBr. So K is potassium, Br is bromine. So the name will become potassium bromide. Okay, naming binary ionic compounds for metals with variables. So again, in rule number 1, use the elemental name of the metal for the metal cation. Determine the ans ion charge or the cat's ion charge. A Roman numeral follows the metal ion to indicate its charge. Number 2, next add the non-metal anions name. The non-metal names suffix changes to IDE. So in simple explanation, so as I have here in the presentation, so the format will become the name of the cation or the name of the metal, followed by the charge of the cation in Roman numerals in parentheses or the charge of the metal, and then again, the base name of the anion or the non-metal plus the IDE. So, in this step, we're going to add the charge of the cation or the metal in a Roman numerals in parentheses. But how are we going to get this charge? Okay. So first, we have to know the charges of the cation and the anion in order to get the charge of the metal that we are going to put in Roman numeral in parentheses. Okay, so we have the positive ions and the negative ions. So positive ions or the cations, for positive charge, we have the positive 1 charge, we have the ammonium, copper, the lithium, potassium, silver, and sodium. For positive 2 charges, we have the barium, the calcium, copper, iron, lead, manganese, nickel, strontium, tin, and zinc. For positive 3 charges, we have the aluminum and iron. For positive 4 charges, we have the lead and tin. Now, it is the most important that we are going to use to get the value of the Roman numeral that we are going to write is the negative ions or the non-ions. So, for the negative 1 charge, we have the acetate, bromide, chloride, dihydrogen phosphate, fluoride, hydroxide, hydrogen carbonate, hydrogen sulfate, hypochlorite, iodide, nitrite, permanganate, thiocyanate. So for negative 2 charge is we have the carbonate, chromate, dichromate, hydrogen, phosphate, oxide, oxalate, sulfate, and sulfite. Now for the negative 3 charges, we have the nitride and the phosphate. Okay. So in order for us to understand more, how are we going to get the value of this Roman numeral? So I am going to show you a video.
So, how would you name these two Lewis structures? We know the first element is iron, and the last element is oxygen, but for ionic compounds, we would write oxide. But how would that distinguish the first one from the second one? They're both iron oxide. So, whenever you have whenever the metal has multiple charges, you need to use Roman numerals to specify which compound you have. It can be iron 1 oxide, iron 2 oxide, iron 3 oxide, iron 4 oxide. We need to know which one we have, although 2 and 3 are more common. So, we need to find the charge on iron to find out which Roman numerals to use. So how can we do that? Well, let's take the first one for example, Fe2O3. let's write an equation. We have 2 Fe atoms plus 3 oxygen atoms, and the net charge is equal to 0. Now, you can replace Fe with X if you want, because we're going to solve for it. And we need to find out what the charge of oxygen is. Based on the periodic table, oxygen as an ion has a -2 charge. Because it has 6 valence electrons, it needs 2 more to get to 8. And once it acquires those 2 electrons, it's going to have a charge of -2. So we're going to substitute oxygen with -2. And we're going to solve for X. So 2x minus 6 is equal to 0. Move the 6 to the other side, 2x equals 6, x is equal to 3. So therefore, iron has a +3 charge. So this compound, the name of it is iron 3 oxide. Let's do the same for this one. So we have 1 Fe atom plus 1 oxygen atom. We're going to set it equal to 0. So x plus, we're going to plug in -2 for oxygen and solve for x. If we move the -2 from the left side to the right side, x equals +2. So therefore, to name that particular structure, it's going to be iron 2 oxide. For the sake of practice, let's try a few more examples. Let's say if we want to name CuCl and CuCl2. So copper plus chlorine should equal 0. We're going to solve for copper. Chlorine, based on the periodic table, has a -1 charge. So x equals +1. So copper has a +1 charge. So therefore, to name it, we're going to say copper 1 chloride. Okay, let's look at this example over here. We have Cu plus 2Cl. We're going to set it equal to 0. And we're going to plug in a -1 for Cl. So x minus 2 is equal to 0, so x is equal to 2. So copper has a +2 charge. So then for this example, it's copper 2 chloride. Okay, let's consider one more example. Let's say if we have SNO and SNO2, tin oxide. So here we have Sn plus oxygen. We're going to set it equal to 0. Replace Sn with x, substitute oxygen for -2, therefore x is equal to 2. So tin has a +2 charge. Here we have tin plus 2 oxygen atoms equals 0. So x plus 2 times -2, so that's x minus 4. Move the 4 to the other side, x is equal to +4. So to name these two compounds, here it's tin 2 oxide, and this compound is called tin 4 oxide. And there you have it. So that's how you can name ionic compounds with Roman numerals. So first you need to figure out what charge the metal has, and then write the name of the formula. And that's all I got for this video. Hopefully.
Okay, name of variable ions. Use Roman number after the name of the metals that forms 2 or more ions. Okay, for example, so FeCl, so it is named as iron 3 chloride. Again, the metal will be written first, followed by the charge in Roman numeral in parentheses, and then followed by the non-metal adding the suffix IDE. So FeCl again is iron 3 chloride. So in order for us to understand more about naming binary ionic compounds with variable ions or with Roman numerals, I have here some examples. Okay, example number 1. Okay, CuCl. So in the first example, so I have here the CuCl. So as you can see, so I write the Cu here plus 1. Cl is equals to 0. 1 Cl because the atom in Cl is only 1. So Cu plus 1 Cl is equals to 0. Then second one is Cu plus 1 times -1. Because the charge of the Cl is -1. So that's why Cu plus 1 times -1 is equals to 0. Next is Cu plus -1, y -1, positive 1 times -1 is equals to -1 is equals to 0. And then next, we're going to transfer the charge from left to right. So it will become from negative, it will become positive 1. So the value or the Roman numeral that we are going to put in the copper is positive 1. So it will become copper 1 chloride. So that is for the first one. So that's why the answer is copper 1 chloride. So and the second one is we have the CnF4. So again, in the CnF4, again, on the left side, I write the symbol of the tin, which is Cn, plus 4 times F is equals to 0. So, Sn plus 4, the charge of the F is -1. So, Sn plus 4 times -1 is equals to 0. Now, Sn plus -4 because 4 times -1 is -4, is equals to 0. Now, again, we are going to transfer the charge from left to right. So, it will become, from negative, it will become positive. So, Sn is equals to positive 4. So, SnF4 will be named as tin 4 fluoride. Okay, the third one. The third one is we have the PbCl, the tin and chloride. So, in this example again, so PbCl, so Pb plus 2Cl is equals to 0. 2 because the atom in chlorine is 2. So, PbCl plus 2, the charge of the chlorine is -1. So, 2 times -1 is equals to 0. Now, Pb plus -2, y -2 because 2 times -1 is -2 is equals to 0. Now, again, we are going to transfer the charge from left to right. So, it will become Pb is equals to positive 2. So, the answer will become lead 2 chloride. Okay. And then, on the last example is we have the Fe2S3. Okay. So, in this example, we have 2 atoms of Fe or iron, and we have 3 atoms of sulfur. So, in this case, we're going again to write 2 Fe plus 3 times S is equals to 0. So, instead of Fe, let's use X because we're going to find the charge of the metal or the Fe. So, it will become 2x plus 3 times -2 is equals to 0. Now, 2x plus -6 because 3 times 2 is -6 is equals to 0. Now, in order for us to get the charge of the iron, let us divide both sides by 2. So, it will become 2x divided by 2 plus -6 divided by 2 is equals to 0. Now, cancel. So, it will become x plus -6 divided by 2 is we have -3. So, x plus -3 is equals to 0. Again, transferring the charge from left to right, it will become, from negative, it will become positive. So, x or iron, or the charge of the iron is positive 3. So, the name will become iron 3 sulfide. Now, let us proceed in naming binary covalent compounds. So, binary covalent compounds are compounds that contain only 2 elements. So, let us compare binary covalent compounds to binary ionic compounds. If binary ionic compounds are composed of 1 metal and 1 non-metal elements, binary covalent compounds are composed of 2 different non-metals. So, these covalent or binary covalent compounds are named using a procedure similar to that used to name simple ionic compounds, but prefixes are added as needed to indicate the number of the atoms of each kind. So to understand more about this, let us go on with the procedure or the diagram in figure 2.13, naming covalent inorganic compound. So the first one, place the elements in their proper order. Okay, name the nonmetal farthest to the left on the periodic table by its elemental name. Second, name the other nonmetal by its elemental name and an IED ending. So let's say for example, N2O3. So N is the element furthest to the left or bottom in the periodic table, while O or oxygen is the element furthest to the right or top in the periodic table. So the third one is use prefixes mono, di, tri to indicate the number of the element or the element in the molecule. So let's say for example, nitrogen. So in nitrogen, we have 2 molecules of nitrogen present. In oxygen, we have 3 molecules or atoms of oxygen present. So we're going to name it as dinitrogen trioxide. So we're going to use prefixes to indicate or identify the number of atoms in each element. And then additional, if mono is the first prefix, it is understood and not written. So if the first prefix is mono, we do not have to write it. Just write the elemental name. Okay. So example. Okay, so I have here the prefix and the number. So mono means 1, di means 2, tri means 3, tetra means 4, penta means 5, hexa means 6, hepta means 7, octa means 8, nona means 9, deca means 10, undeca means 11, and dodeca means 12. So examples. SiF4. Okay. So how are we going to name this? So the elemental name of the Si is silicon, while the elemental name of F is fluorine. But instead of writing fluorine, we're going to get the root of the elemental name of fluorine plus adding the suffix IDE in the ending. And then we're also going to identify or use suffix to identify the number of the atom present in the element. Example, K. So SiF4, Si is silicon, F4, it has 4 atom, and the suffix for 4 is tetra, so it will become silicon tetrafluoride, because tetra refers to the number of atom present in the element, so it is 4. That's why it is tetrafluoride. Okay, second one, NO3. So N is nitrogen and O is oxygen, but it is composed of 3 atoms. So we are going to name this as 3 means trioxide. So NO3 is nitrogen trioxide. Okay, next one is CF4, C for carbon, and F for fluorine. So we have 4 atoms of fluorine, and the suffix that we're going to use is tetra, because tetra means 4, so it will be named as carbon tetrafluoride. And then the fourth one is UF6. Okay, so U means uranium and F means fluorine, but it is composed or made up of 6 atoms, and the suffix for 6 is hexa, so it is named as uranium hexafluoride. Now, let us go on with the rules in writing chemical formula. So, binary compounds of metals and non-metals. So, here are the rules in writing the chemical formula. The first one is write the symbol of the elements. Second is write the positive oxidation number of the first element, followed by the negative oxidation number of the second element. Third is drop the positive and negative signs. And then 4, crisscross the superscripts. So, let us have an example by following the rules. Okay, the first rule again is write the symbol of the element. So, we have aluminum sulfide. So, let us write the symbol of the elements. So, we have Al for aluminum and S for sulfide. Now, second rule. Write the positive oxidation number of the first element followed by the negative oxidation number of the second element. Okay, so based on the periodic table, the oxidation number of the aluminum is positive 3 and the oxidation number of the sulfide or sulfur is negative 2. Okay, number 3. Drop the positive and negative signs. Okay, so drop the positive and negative signs. So we have Al3 and S2. And then next one is crisscross the superscripts to make it the subscript. Okay, so 3 for sulfide or sulfur and 2 for aluminum. So it will become Al2S3. So that would be the chemical formula of aluminum sulfide. So Al2S3. Now second is we have the zinc chloride. So again, write the symbol of the elements. So Zn for zinc and Cl for chlorine or chloride. Second, write the positive oxidation number of the first element followed by negative oxidation number of the second element. So the oxidation number of zinc is positive 2 and the oxidation number of chlorine or chloride is negative 1. Now again, step number 3 is drop the positive and negative sign. So I have here now Zn2 and Cl1. Now, the fourth step is crisscross the superscript to make it the subscript. So, 2 for Cl and 1 for zinc. So, it will become ZnCl2. So, the chemical formula for zinc chloride is ZnCl2. Now, let us proceed with naming binary compounds of nonmetals. First, write the symbol of two elements. Second, there is no need to write the oxidation of each symbol because the prefixes indicate the respective number of atoms. Okay, so let me show you again the prefix and the number. Mono means 1, di means 2, tri means 3, tetra means 4, penta means 5, hexa means 6, hepta means 7, octa means 8, nona means 9, deca means 10, undeca means 11, and dodeca means 12. Okay, so for example, silicon tetrafluoride. So, the term or the suffix tetra means 4. So, how are we going to write it? So, the symbol of silicon is Si, and the symbol of fluoride or fluorine is F. And then, we're going to indicate the number of atom in fluoride. So, tetra means 4, so it will become SiF4. Second one, nitrogen trioxide. So, the symbol of nitrogen is N. So, the symbol of oxygen is O. While the meaning of tri or the suffix tri is 3. So, it will become NO3. Okay, the third one, carbon tetrafluoride. So, the chemical symbol of carbon is C, while the fluoride or fluorine is F. Tetra means 4, so it will become CF4. Okay, number 4, uranium hexafluoride. So, uranium is U, fluoride or fluorine is F, and hexa means 6. So, the chemical formula will become U. That's all. Thank you.